And it's given in this particular sum. Quadrilateral PQRS is a rhombus and diagonals are intersecting at point T. We are supposed to prove sum of the squares, all four sides, okay? Sum of the squares of the four sides of the rhombus is equal to sum of the squares of the diagonals. Diagonals ka square, did you understand? So they have given sum of the squares of all the four sides of the rhombus is equal to sum of the squares of their diagonals. Now children, rhombus, all four sides are equal. Next factor, the diagonals of rhombus are perpendicular bisectors, but I won't use the property of perpendicular, but I will use it as bisectors. If the diagonals are bisector, that means T is a midpoint of QS. In the same manner, T is midpoint of PR. Okay? So, we will try to first get some raw materials. First, we can put it up like this. PT is half of PR. Is it right? Then RT is also half of PR. QT is equal to TS is equal to half of QS. Reason for all this will be diagonals of rhombus bisect each other. Okay, this values I will use it later on when I substitute it. Now please concentrate on triangle PQS. Okay, so point number 2, in triangle PQS, sec PT is a median. Is it right? Can sec PT can be a median because T is a midpoint of QS. So if I hold vertex P and apply Apollonius, so what do I get? I will get PQ square plus PS square is equal to 2 times PT square plus 2 times QT square. This is by Apollonius theorem. Okay? Now I'll try to substitute PT's value and QR's value. So what I get is PQ square plus PS square is equal to 2 into PT. PT is half of PR. Half PR the whole square plus 2 into QT. QT's value is half QS the whole square. This I am getting from statement number 1. So this gives me PQ square plus PS square is equal to 2 into 1 upon 4 PR square plus 2 into 1 upon 4 QS square. So can we cancel it? 2 1s are, 2 2s are, 2 1s are, 2 2s are. Okay? So this gives me PQ square plus PS square is equal to 1 upon 2 PR square plus 1 upon 2 QS square. Now this is what I've got by applying Apollonius in triangle PQS. So if you see, I've got PQ square plus PS square, PQ square plus PS square of my 2 prove that. Now something else is left, QR square plus SR square. That means in triangle QRS down below here, I have to again apply Apollonius. So what will I write here is point number 3. Similarly, in triangle QRS by Apollonius theorem, what will I get? I can get QR square plus RS square is equal to same thing like what I've got here. It is half PR square plus half QS square. Okay, so this is the second box what I've got. Now I can add LHS and RHS. If I add LHS now in this case, I'll get even QR square plus SR square which was missing. So I'll add up these two things. That gives me point number 4, PQ square plus PS square plus QR square plus RS square is equal to, children, half PR square plus half PR square. Half PR square plus half PR square will give me just PR square. Is it right? When I remove LCM and add up, if you want to see this particular part, it is half PR square plus half PR square. So LCM is 2. So PR square plus PR square, that gives me 2 PR square upon 2. The 2 gets cancelled. So this is how I get what? Half PR square plus half PR square is equal to PR square. Plus here half QS square plus half QS square again gives me QS square. This is by adding statement number 2 and 3.